Afternoon, sir.
Hey, Shimon, how you doing?
Pretty good, sir. And you?
Um, I'm doing good. I'm doing thanks.
Great, great.
Nice. Were you able to look through the two questions that we did in class? Well, I know you would, but you understand it? Shamari?
Hold on, sir. I mean, if I see the flow of it and know what I should do first and think that, yeah, I understand it, sir. I just don't know the steps out of my head right now.
No problem. So do me a favor. Early bird get the first worm. I just um put up one on the screen. Are you seeing it?
Yes, sir.
Mm. Try and make some headway with that. Just try. I have not yet done it either. Just try it, and then we can have a conversation on it.
All right, sir.
Cool. And as you work, I'm gonna ask you to see if you can put the steps mentally. Cement the steps in the head mentally because I feel like one of them is coming, but do you think?
Sir, as the never says, it's stuck in traffic.
Thanks for the update. Shamari, I'm not hearing you breathe or anything at all. How you stay?
I'll say you go when me at work, sir. Me.
All right, then cool. All right, go on. You all right though? You're finding a way through?
Yeah, I think me have find a way, sir.
All right, let me ask you a question. Where you for X?
In this case, because I think we just have find X would have no, I'm gonna find it yet, sir.
I'm gonna find X here. All right,
No,
cool.
sir.
All right, one do you think? I'm working the question now too. Cool.
All right, sir. Sir, last time I asked when we are getting the test.
Try for open come a class.
All
All
right.
right, cool.
Sir, does X equal 1? Sir, yeah, you hear me?
You were saying something before?
Yes, sir.
Oh, sorry, I
Me
didn't
did
hear it.
I ask you? Me did I ask you if x equal 1?
Um, so you find the value of x already?
Is it 1?
I didn't get one. Okay, so when you differentiated the function in conjunction with the constraint, what did you get?
2x minus 2 equal 2 lambda x.
Excellent. Next one is
2y minus 2 equal 2 lambda y.
excellent. Now, when you, what is the next step?
So find x in terms of lambda.
Very good. So when you have 2x minus 2 lambda x, sorry, when you have 2x minus 2 equals 2 lambda x, you're trying to find x in terms of lambda. So what did you do how did you, what you got for x in terms of lambda?
So what I should have is x is equal to 2 over 1 minus lambda multiplied by 2.
There's 2 over,
No, yeah.
is it multiplied by 2?
2 over 2 into 1 minus lambda, is that it? Or is it 4 over?
All right, simplify it first and tell me what lambda is. Do the simplification and tell me what to get for lambda. Because
Alright,
that's not what I get, but it's something close to that I get. So I may be wrong, so you can let me know.
alright.
I'm right here now, don't go too far. I'm not even muting.
Yeah, okay. What X is equal to 1 over 1 minus lambda.
Very good. That's what I got. X is equal to 1 over 1 minus lambda. Okay, what is y?
Why would it be 1 over 1 minus lambda?
As well.
Yeah.
What's the next step? So that's the second step. And the second step now is to solve for x and y in terms of lambda. That's what you just did. What is the third step? We now need to
Plug
substitute
them in.
into the constraint, right?
Yes, sir.
Okay, plug it into the constraints now and tell me what it is that you have.
Good evening.
Hey, sir, did you get a quadratic expression?
Well, I got 1 over 1 minus lambda squared plus 1 over 1 minus lambda squared equals 16. Where you get? Oh, Rockstone. Where you get? When you substitute the value of x and y, oh, the same difference. Same difference. If I did that, I could be the same thing. Talk to me now. And the
Middle
rest of
attack.
it.
Middle
Huh?
attack. Middle attack on you.
Oh,
Uh, yeah, when we work out the 1 over 1 minus lambda square plus 1 over 1 minus lambda square equals 16, we
mm-hmm.
get 2 minus 4 lambda plus 2 lambda square equal 1 over 16. So we're going, in order to find lambda mode, wait, we wouldn't be able to solve that because it's not equal to 0.
I may need to take over because I did something a little different right there. So, I did something a little different right there. So, all right, let me take over. The rest of you, were you able to try it?
Um, I don't really so far in sir, but you know, stuck same.
All right, where got to?
All right, sir. All right, so I was trying to find x.
Where you get?
I got 1 for x. And then we try something to find the lambda, and I get -1.
Um,
And then
that's
we
not.
running it out now, and that's one like it wrong.
Yeah, that's not what we got. All right, let us. Um, I was only looking at the question now because I I found this question and I say, you know what? Let us give it an attempt. Found the question and I said, let us give it an attempt. All right. See my screen, right?
Yes, sir.
All right. So it says to find the maximum and minimum values of f of xy is x squared plus y squared minus 2xy minus 2y plus 14. Now, this one, the answer didn't come out so well for me. In my headspace, never come out oh so nice. But what I wanted to do is to be able to show you some steps. You can know the steps in order to do the question. It's not like it in an online exam where, or an open book test where you have something to guide you. You would have to rely on it from memory. So I was more interested in writing the steps, like a summary step for you to follow. Okay, so I'm gonna differentiate. So I'm gonna get
Good evening, sir.
hey Papa, hello. I'm gonna get 2x minus 2 is equals to 2 lambda x. Tell me if you agree with that.
Agree, sir.
Sir?
You agree with that?
Yes, sir.
All
Sir,
right.
just a
Uh-huh.
minute. All right, so I was looking at the recording. Sorry to disturb the class, but all right, so I was looking at the recording today, but the lambda sign, how do I get that? Because I'm looking on the calculator, I'm not seeing anything for that.
You calculated like that. Don't worry
Oh,
about you calculated it. You're not going to see the lambda on the calculator.
okay, all right.
Mhm. All right, and then now, and if you want, I could just show you that x squared minus 2x plus y squared minus 2y plus 14. I'm just rearranging there. So you know right there, I will differentiate that, and then differentiate that. All right. And then I'm going to get 2y minus 2 is equals to 2 lambda y. Agreed?
Yes, sir. Yes, sir.
Yes,
2
sir.
marks, sir.
Huh?
Yes, sir. That is 2 marks.
Yes, sir.
Good, good. Out of how much?
So the question can come about 10 marks, 10, 12 marks, as much as 15 marks, depending on the length of the question. But it's a big marker too. To be honest with you, this question carries round about the same mark like the Newton-Raphson and um the trapezoidal and the Maclaurin's. So you can get this as one question. You can, and the Hessian matrix. So you could get a Hessian matrix for 10 marks. You can get the Lagrange for 10 marks. Or you can get the Hessian matrix for 8 marks and the Lagrange for 12 marks, or 20 marks. And then you get a Newton-Raphson for 10 marks. Or you may get a volume question. Did I show you how to calculate the volume? Rotate it about the x-axis or the y-axis?
Yes, sir.
Yes, sir.
Yeah, man. That you could get any other. Them question, they are 10-mark question. It's like the topics in a calculus 2, a big mark question then. And then the biggest mark is going to be your multivariable function, which I'm expecting to have about 30 marks. So I'm saying to you, if you understand these topics, you can go into the exam and you can shell it. All right. So I did, as I'm speaking, I did look to see if I've covered all the areas, and there's one area that keeps hiding from me. So when I thought I had one area to do, I now have 2 areas, but I'm not worried because after this, today's what? Today's Wednesday. On Friday, God's willing, I can start the multivariable function because I'll just spend today on Lagrange. If I finish Lagrange in another, it's now 6 minutes past, 7 minutes past 6. If I finish this at about 6:30, maybe I can drop in a double integration and show you a thing or two, because that is not hard. I can use half an hour and finish that. Because you know how to integrate, it's just some tricks that I want to show you. And I was looking for a video and I think I found a video for you, so I can share it with you. It's not difficult. And then I could use Friday. I could use Friday to just run through the other topic. So there is, and that's differential equations. And when I finish differential equations, I'm finished. My aim is to finish teaching this Friday. That's my aim, to finish teaching this Friday. So we can have next week for us touch upon some areas. All right, let's go. Let's go. Let's go. Let's go. Where am I now? Okay. So what I want to do is to get some is to help you to understand what is happening. So what I'm doing here is I'm differentiating as my first step. I'm differentiating the function f of xy in conjunction with, look how me spell with, because I'm writing two words in one, with the constraint. Does that make sense?
Yes, sir.
All right. So what I'm aiming to do is to help you to get those steps in. And then now, I need to work with me now, because I mean, as I said before, I'm seeing this question for the first time too. And then now, what we need, the next step is to solve for x and y in terms of lambda, no so?
Yes, sir.
Definitely.
All right, so let me just write that step 2 is to solve for x and y in terms of lambda. All right, so that's step 2. So this was 1. Let us look at step 2 now. Solve for x and y in terms of lambda. So remember, when we're doing this step, we have to be careful because we don't want to throw out any of our values. We don't want to throw out any of our values like I showed you the last time around. So what comes to my mind is this, and tell me if you agree with it. 2x minus 2 lambda x is equals to 2. So therefore, 2x into 1 minus lambda is equals to 2. And I want to find x. So I'm going to say 2, 1 minus lambda. 2 into 1 minus lambda. You agree with that so far?
Sorry, can I run that again, please? Because I'm trying to catch on to this topic because I missed some class, but I'm watching the video, but I haven't fully grasped the whole concept of it.
You understand step 1?
Yeah, man, yeah, man.
All right, so step 2 is me trying to make x the subject for the formula in the first equation. In the first equation, I'm trying to make x the subject for the formula. So what I'm trying to do is to isolate my x's. When I say isolate my x's, I want all the x's to be on one side and everything else to be on the other side. So what I did was to subtract 2 lambda x from both sides. So I will get 2 minus 2 lambda x. And then what I'm going to do is to add 2 to both sides. So I'm going to get it equals to 2. And then what I'm doing is factoring out the 2x because 2x is common there. So I'm factoring out the 2x. And when I factor out the 2x, I'm going to get 2x into 1 minus lambda, which is equals to 2. And then I'm dividing both. I want x alone to be on one side. I want x alone to be on one side. I want x alone to be on one side. So everything outside of x, I'm going to divide by. So this 2 I don't want, so I'm going to divide by the 2. This 1 minus lambda I don't want, I'm going to divide by the 1 minus lambda. So technically now I'm dividing both sides by 2 times 1 minus lambda. See here, 2 times 1 minus lambda. So when I do that,
Solving for x.
I'm solving for x. So
Right.
x now is going to be equals to, oh, sorry. This 2 cancels with that 2. So x now is going to be equals to 1 over 1 minus lambda. I know Shamari got that. So I'll get ask the rest of you. So I got my x to be 1 over 1 minus lambda. Remember, I'm solving in terms of lambda. Anybody else got that? Or if you didn't, are you seeing how I got that? Shamari has that. So Shamari and I agree so far.
You know, I get it.
Okay. What about the rest of you?
All right, sir. I understand it, sir, but see, last class, sir, when you add 2y bracket 1 minus lambda equals 0, we end up with
Yeah.
we have y equals 0 and lambda equal how much again?
Yeah. All right. Let me pause you. I remember what you're talking about, Papa. I remember exactly what you're talking about. But put it this way. Your stew chicken is different from my stew chicken, but it is still stew chicken. Make sense? Does that part make sense?
Yes, sir.
All right, good. So what we're doing, we're making x the subject of the formula. So depending on what the equation looks like, I may have to take a different route. So the last question that I did, it was a little special because right up front, we got a value for y. Y was equal to 0 or x. No, I think y was equal to 0. So right there and then it just boom, gave us a value for y. We never had that. We never had that in the first question, and we're not going to have that in this question, basically. So that question was a little special because as we work it, we got one of the answers right off the bat. Y equals something. And then now y equals 0, and then now x was equal to maybe like I think 1 minus lambda. It's circle, right? I'm speaking from memory. Something like 1 minus lambda, whatever it was. So you have to be careful not to be stereotyped. Just work the equation. It's just like you go into the exam and know so the man them give you simultaneous equation. You don't know which equations they're going to give you, but you know say simultaneous equation you have to use. All right. So yes. So in this case, we're not going to get two sets of answers, Chevy. That's the point I'm making. In this case, we just get x equals 1 minus lambda. And then we have to go work out the y value now. Follow me?
Okay.
All right. Because if I remember right, we got something like y equals 0, and then something like 1 minus lambda equals 0. So therefore, lambda was equals to 1. So we end up getting our x value and a value for lambda. So when we're ready for the second equation, all we did was also substitute lambda in the second equation, and we're good to go. All right. But remember, that's what I'm saying. The aim for the step 2 is to solve for x and y in terms of lambda. We are solving for x and y in terms of lambda. Sometimes we get our values up front, and it depends on what the equations look like. Anyhow, let's go. So x is equals to 1 over 1 minus lambda. I'm going to try to use the second equation now to find out what y is equal to. I'm going to say 2y minus 2 lambda y is equals to 2. Do you agree with that?
Yes, sir.
Right? The rest of you?
Yes, sir.
Nice. If you work with me, you're good to go. All right. All right then. So now, 2y is common, so I'm factoring out the 2y. I'm going to have 1 minus lambda is equals to 2. And then, similar to what I did before, I want the value of y. I'm going to divide both sides by 2 times 1 minus lambda. That 2 cancels it, that 2. That cancel that 2 here cancel the 2 here. And you see what that is that I did? Y is equals to 1 over 1 minus lambda. Somebody may say, but sir, since you want x, why factoring out 2x? Because if I didn't do that, look at what is happening here. If I only factored out the y, I'd have had y into 2 minus 2 lambda is equals to 2. And if you divide both sides by 2 minus 2 lambda over 2 minus 2 lambda, that cancels that, so you have y is equals to 2 over 2 minus 2 lambda, which is incomplete. So you'd have to go ahead and factor out the 2 down here, 2 into 1 minus lambda, and then that cancels that, and then y is equals to 1 over 1 minus lambda, which is technically
Just longer.
lambda. Oh, it's longer. Oh, you said longer. Yeah, it's longer. Yeah. So I just packed up my stuff right there and then. Right?
Sir, explain that part here again now. The first part, the 2y minus 2 lambda y equal to.
What? Explain this?
Yes, sir.
All right.
The second.
But you recognize that that's the second equation, don't?
Yeah, man.
All right. So that being the second equation, I want y to be the subject. The y's are common. So I'm factoring out the y, but it's not just y that is common. I have all of 2y that is common. So I'm factoring out the 2y. So I'm taking out the 2y. See the 2y right here? What is left?
Yes.
I'm going to have 1 minus, I took out the 2 and the y, so we have lambda left. So we have 1 minus lambda. See that?
Oh.
And it's equals to 2. And then I'm going to divide both sides by 2 times 1 minus lambda. 2 times 1 minus lambda. All right? And then I'm going to have y left on this side. And then I'm going to have these 2's will cancel out. So that's going to have 1 over 1 minus lambda. So what I want to do is to find x and y in terms of lambda. So if Sweeter says solve for x and y in terms of lambda. Good so far?
Yes, sir. Thanks.
All right. Now, the third step, if we can recall, is now to...
Before you move on, sorry for cut you.
Mm.
You could explain what you have on the right-hand side to get back the same equation.
So what I did was to, instead of factoring out the 2 lambda, I just factor out the y. Since somebody may say, but sir, it's not 2y you want, it's just y, so why factoring out the 2y? I said, okay, fine. I suppose anybody say it's 2y that is common, I don't know why you see, because you want y to be the subject. It's not a problem. So I would factor out the y from here. And when I take off the y from here, I'm left with 2. See it right here, so? And when I take off the y from here, so I'm going to be left with minus 2 lambda. See it right here, so? And equals to the 2. Then I divide both sides by 2 minus 2 lambda. So this cancels this down here. So we're going to have 2 over 2 minus 2 lambda. So I would say now y is equals to 2 minus 2 lambda. And then I say, but hold on there. I can factor out a 2 from the denominator. And that 2, when I factor from the denominator, I'm going to get 2 times 1 minus lambda. See here? 2 times 1 minus lambda. And then this 2 and this 2 cancels out. So I'm left with again now 1 over 1 minus lambda, which is exactly the same as I have before. So whichever method you do is the same thing. So that this one I did it one shot. This one I have to do it and then do something else again. Make sense? You follow?
Yes, sir.
All right, good. Anybody remember the third step? What's the third step? When we find x and y, what we're doing?
Substitute.
Very good. So the third step now, the third step is that we're going to substitute I'm going to substitute x and y into the given constraint. Into the given constraint. Recall, x plus y, x squared plus y squared minus 16. X squared plus y squared minus 16. So that's a constraint. That's a constraint. So I'm going to substitute my x and y in it. Ooh, what's my x? My x is 1 minus lambda. No, 1 over 1 minus lambda all squared plus y, which is 1 minus lambda. Oh, both of them are the same. All squared minus 16 equals 0. Mm. All right. Shamari, I am going to do this differently than how you said that you did yours. You expanded, me now do no expansion. Look at what I'm going to do. That is the same thing as 1 squared over 1 minus lambda all squared. Can you see that? Can you see what is happening here?
Yes, sir.
My 1 over 1 minus lambda squared is the same thing as squaring the numerator, squaring the denominator. All right? I'm doing that because I want to show you something. And then I'm going to say equals 16, don't it?
Yes, sir.
Equals 16. But, come on, don't do this to me. No. One squared is 1. So that's just 1 over 1 minus lambda all squared. And 1 squared again is 1 over 1 minus lambda all squared. And that is equal to 16. Now I'm trying to bring these two fractions to a single fraction. And I'm going to have my denominator as 1 minus lambda all squared. Talk truth.
Yes, sir.
So 1 minus lambda all squared into 1 minus lambda all squared is going to be 1 time. And 1 times 1 is 1. And the same 1 up here. And all of that is going to be equal to 16. So 1 plus 1 is 2. So I'm going to have 2 over 1 minus lambda all squared equals 16. And see me try to fight with this, to add a page. And I know I know exactly what is going to happen. Um, all right. Let me just fight a little to add a page. It does this every single time. And I recognize I have to close out some of the little something that I have open. And it didn't work this time, but let me go again. And I don't know why I never open several pages, I'll come in here, guys. Forgive me. Just Mhm. You can't believe I'm still trying to sort this thing out. And I have to find a different way of adding the pages. This conventional method not working. That's footer. I don't want the footer, so I press it right there. All right. If this don't try this, if it don't work this time, I'm just gonna I don't know why anybody do it. Jesus. All right. I'm not gonna fight with it anymore. When I keep adding the page, the question that I copied in here keeps coming down. And um, I'm cutting that. All right, see the page is there now? So I'm cutting that. Let me just add another page. Add another page. All right, so the pages are added nicely. So I have 3 pages. Let me see if I can go up here now and paste. Oh, Samina smart. Talk to me nice. Astanil, talk to you, teacher nice.
Always.
Wow. All
Sarah,
right.
in the chat.
Yes, Papa. All right. So I am where I want to be now. All right. Good.
Heard?
Sorry. Say that again. That's
I sent a
Nike.
message to you in the chat.
Oh, you sent a message to me. Um. I responded to you. I saw your response. All right. So now, all right, let me do this now so I can continue with what I'm saying. All right, good. So now what I'm gonna have, I have 2 fractions separated by an equal sign, so I'm going to cross multiply. So what I'm going to have is 2 is equals to 16, 1 minus lambda all squared. Tell me if you agree with that. And then now, because my aim is to find lambda. That's what we're trying to find. Substitute x and y in terms of the given constraint here. So my aim is to find lambda because I substitute for x and y. It's only lambda alone I have. So I'm dividing both sides by 16. So I'm going to have 2 over 16 is the same thing as 1 over 8, don't? Agree or disagree?
Agree.
Agree, sir.
And then now, in order for me to find that, you would always also agree with me that I need to find the square root. So we have the root of 1 over 8 is equals to plus or minus 1 minus lambda. Because now I get rid of the square root sign. Don't. I mean, not get rid of the squared sign. Don't.
Yes, sir.
Can you repeat that, sir?
Now I'm just saying to you, what I'm saying to you is, I have 1 over 8 is going to be equals to 1 minus lambda squared. So I'm taking the square root of both sides. So when I take the square root of both sides, I'm going to have the root of 1 over 8, which is now going to be equals to plus or minus 1 minus lambda, because this square gone. Don't.
Yes, sir.
Yes, sir.
Mm-hmm. So this is either the root of 1 over 8 equals to 1 minus lambda, or the root of 1 over 8 is equals to negative 1 minus lambda, which works out to be, lambda is equals to 1 minus the root of 1 over 8. And this is the same thing as, let me write it in another color, minus 1 plus lambda. Can you see that? Minus times a negative, minus 1 times a negative times a positive 1 is going to be negative 1, and negative 1 times a negative lambda is a positive lambda. You see that?
Yes,
Yes,
sir.
sir.
So lambda in this case is going to be equals to the root of 1 over 8 plus 1. Now, this is where I'm going to pause and ask. Yes, you may not be seeing. One of the things that I'm doing tonight that is different is writing the steps. And so far, we are at step 3. We need to finish all the question, and then we can know how many steps we're supposed to be doing, so that if you are doing the question, at least you know this is step 1, this is step 2, this is step 3, and how many other steps we have in the question. Now, all of what we're doing here is just really algebra. The calculus ended from the first line when we differentiated the function and equated it to the differential of the constraint. Everything thereafter is algebra. Do you agree with me or do you disagree with me?
Agree with you.
Yeah, man. We don't do no more differentiation. We don't do nothing more. All we just doing is just pure algebra. Pure algebra. So this is where your discrete math and algebra now comes into play. Pure algebra. All right? So we're continuing. I'm in 2 minds right here, so. I'm in 2 minds. I can tell you I'm in 2 minds. In order for me to find lambda, I'll have to bring that 1 minus 1/8 into one fraction. Surge is not a part of your syllabus. Surge is not a part of your syllabus. So let me just write what, hold on, let me just do it.
Sir, before you get to that, could you just
Sir, why you put the
little
for the
bit
all right, when it for the
Hold up. Asking was asking a question. Go ahead, asking. You're low, asking you.
Am I still low?
No, you're up now.
I was saying if you could backtrack a little bit for me, right where you have the 2/16, the step before that. I'm not sure if I'm seeing how you got the 2/16.
Cross multiply.
1 to 16. Yeah, but
2 times 1 is 2.
2 at the
And
top.
16 times all of this is 16 times all of that. And then dividing both sides by 16.
Oh, okay.
Because I want to isolate, meaning I just want my lambda. Lambda is what I want to be on one side. Because remember, we found x and y in terms of lambda. So I'm trying to find the value now of lambda so that I can substitute it back to my x and y in terms of lambda, which is step number 2. And then now, after that, now, when we get the real value of x and y, because we still don't have a real value of x and y now, because my x value is just 1 minus, sorry, my x value is just 1 over 1 minus lambda. So is my y value. So I'm trying now to find the value of lambda so that I can go ahead and substitute it now into my x and my y. So I can get a full x value and a full y value. So I can now substitute it into my original f of xy function. So the first step is to differentiate the multivariable function in conjunction with the constraints and equate them. Then I'm going to end up with, then I'm going to make one equation with respect to x, make x the subject of the formula for one, then I'm going to make y the subject of the formula for the other. And that is step number 2. Then I'm going to, actually, that is step number 1 still. Well, technically step 2, but anyhow. And then now, when I get the value of x and y, I'm going to substitute that into my constraint. Now, when I substitute that into my constraint, I no longer have x and y. I'm going to have something now with just pure lambda. So I'm going to go down now. All I want to do is to make lambda the subject. I need to find the value of lambda so that when I find lambda, I can substitute back now to my x and y in terms of lambda. So I can get the real values, the true values of x and y, and then I substitute that into my stuff. So it's a whole heap of substitution and thing. But as I said before, this is still algebra. All right. So I was saying to you now, and I may get myself into trouble in doing this, but at this stage,
Sir,
yes, please.
you have diving instead of dividing here.
You see when you go to school and you can read.
Yeah, but now when you find out, say, at the incorrect thing you have, you say we never did not pay attention.
Are you final? Thank you, my love.
Yeah.
Jesus. All right, let's go. You see, I want Shamari and Chevy and the rest of them not say nothing to me. I laugh them one laugh for me. All right, let's go. So I'm saying to you, oh Lord, I'm going to get myself into trouble here, but I'm going to do it nonetheless because we need to finish up the question. I'm going to write what. All right, I'm just going to don't ask me how I get it because I'm not teaching you that. It's not on your syllabus and I'm not teaching you. I'm just going to show you. In the event that you show somebody something and them say, why I'm doing it like that? We want to just show you something here. So lambda is going to be equal to that will be the root of x, the root of 8 over the root of 8. The root of 8 over the root of 8 is 1. So it's going to be 4 minus the root of 2 over 4. 4 minus the root of 2 over 4. That's what it works out to be. That's what this works out to be. But don't pay this to mind. And then lambda here is going to be the root of 8 over the root of 8. So the root of 4 plus the root of 2 over 4. Now, all I'm doing here now, right at this point, I'm just going to put this into my calculator. 1 minus the root of 1 over 8 and just work it out. Like I'm working out all of this here. So I'm going to get lambda equal, and I'm just going to use 2 decimal places. 0.65. Work that for me, please, and tell me if I get. Work 1 minus the root of 1 over 8 until I get. Not x lambda.
Yes, sir, I got that.
All right. And check to see if my 1.35 is correct, please.
Yes, sir.
All right. Now, let me pause and tell you what I'm doing, why I'm doing it like that. I'm doing it this way because if I evaluate this as it is here, it will take me a while to teach you the thirds, though that the thirds is not, it's not bad. S-U-R-D-S, S-U-R-D-S. Third is not bad, but the last time I checked your syllabus, I'm not seeing any thirds on it. So I'm not going to waste time to do the stuff. I'm not wasting time to do this stuff. So I give you permission. I'm giving you permission to just, you get something like this, just go ahead and evaluate it. I won't penalize you because SIRS is not on the syllabus and I'm not teaching it to you. So I'm going to have 1 plus 1 minus the 1/8 and the root of 1/8 plus 1, and I get all of those. All right. So now that I have that, my other step is, and I'm winding down, my other step is, that's step 3. Step 4 now. Step 4 is to substitute the values of lambda into x and y in STEP in step 2. No. Solve for x and y in terms of lambda. Yeah, in step 2. All right. So recall x is 1 over 1 minus lambda, and so is y. 1 over 1 minus lambda. X is equal to 1 over 1 minus lambda, and y is also equal to 1 over 1 minus lambda. All right, so recall that. Now, if I'm using lambda to be equal to 0.65, I'm using lambda to be 0.65. I'm trying to find the coordinates there. So we have x is equal to 1 over 1 minus 0.65. Y is also going to be equal to 1 over 1 minus 0.65. X is equal to 1 over 0.35, I think. 6 and 29, yeah. What is 1 over 0.35 equals to? That is 100 over 35. 100 over 35, that's 2 point something. Almost 2.5. No, man,
2.857.
2.86.
Yeah.
2.86. I mean, y is also equal to 2.86. So I can say no, it's not a critical point, 0.86, comma, 2.86. And then now, for lambda equals 1.35, x is going to be equals to 1 over 1 minus 1.35. Y is equals to 1 over 1 minus 1.35. X is equals to 1 over negative, no, yeah, negative 0.35. Y is equals to 1 over negative 0.35. Well, that looks to me like it's going to be negative 2.86. Talk to me.
Yes.
Confirm for me. Negative 2.86, right?
Yeah, minus 2.86.
All right, good. All right, now, and then now the final step. So there are 5 steps to this. The final step. What is the final step now?
Determine.
We're going to substitute the points, not a critical point. We're going to substitute the points into the origin into the original function to determine maximum and minimums. Makes sense, don't? That's what you saw me do, don't?
Yes, sir.
The rest of it gone a bit, you know. The rest of it threw me out. Me know.
No,
But
Yeah,
obviously,
man.
nothing like that.
okay, bless the Lord. Because them something will come on the exam. They come every year. Truth be told, though, the last calculus 2, I didn't remember seeing Lagrange multiplier on it. So therefore, since it never come the last time, I sure say it did it this time. Positive. All right. Fingers kind of tired, so let me just tell you something in 2 minutes. I'm teaching the syllabus. I don't know what questions coming on the exam. I'm teaching the syllabus. However, if when I finish teaching the syllabus and you go into the exam, and every question on the exam paper, you should be able to answer because sir would have taught the topic. Select your best questions. Select the questions. And if, for example, if you say a stationary point, multivariable function, for 30 marks for argument's sake, run with that one day. But if you see the multivariable function come for 15 marks with a Lagrange multiplier for 15 marks, I know, so boy, you understand the Lagrange, you understand the multivariable function. Those are that question is what you're supposed to do, the part A and the part B. If you see a question on something else, 2 other something you know already, but you have limited knowledge on. But this is something else. So boy, the areas that I know is only 10 marks, and the other 2 questions for 20 marks in total. I can't reach to make a lose 20 marks there. So, but you see a question, 3-part question, ABC, And A and B, you know for it, and you can collect 20 marks out of that. And say C now, you can panka, maybe get a 3 or a 4 marks out of that. Run for that question there. What's the point? Go for the question that you have most information about. It's not you, all of you doing one question, so I have only one question to mark. I'm giving you 4 questions on the exam paper. Select your best 2 questions. That's the point. Select your
So,
best 2 questions. Yes, sir.
sorry, we're gonna get how many questions to select from?
Just select, you get 4 questions to select any 2.
Oh, okay.
And you're getting 4 questions at 30 marks each. Select any 2 questions and select your best 2 questions. All right. Let us see if I can finish off now.
Sir, like, how much a question like this? How much marks it carry?
The question are kind of longish. Anywhere between 12 and 15 marks. Anywhere between 12 and 15 marks. And trust me, if it's a 15 marker, this is a half of 1 question. Just know the steps. Follow the steps. There are 5 such steps. This is the last step. So what we're going to do now is substitute this into the original function. Let me do a recall again. F of xy is x squared plus y squared minus 2xy minus 2x minus 2y plus 14 minus 2x minus 2y plus 14 minus 2x minus 2y plus 14. All right, so let me just recall this. Recall. F of xy is equals to x squared plus y squared minus 2x minus 2y plus 14. Did I get it right?
Yes, sir.
Yes, very good.
All right, good. Thank you. Then now we have 2.86, 2.86. So 2.86 comma 2.86. So f of 2.86 comma 2.86 is going to be 2.86 square plus 2.86 square minus 2 times 2.86 minus 2 times 2.86 plus 14. This is pure calculator work now, you know. Matter of fact, put everything one time in the calculator until you get 2.86 square plus 2.86 square minus 2.86 minus 2.86 plus 14 equal. Tomorrow you gonna sleep.
Sure.
Mm.
Wasn't it 2 negatives that you have at the in the previous step?
Yeah, but I'm not using those values yet.
Okay.
Tomorrow wake up. And don't follow Aston. I mean, not Aston, don't follow utterly.
What you saying?
you know, utterly, are you them now no shame now because when she ready for see she gone. True of us, utterly talk true. Okay,
True.
yeah, man. I them have no filter. When she tired, she just gone. As I'm not utterly gone. All right, let's go. What do you get for that one?
I got 18.92.
18.92. All right. And then now F, nope. And then now I'm looking at negative 2.86, comma, negative 2.86. Oh, no, it won't be the same answer. F of negative 2.86, comma, negative 2.86 is going to be negative 2.86 square plus negative 2.86 square minus 2 times 2.86. Nope, negative minus 2 times negative 2.86 plus 14. Do that quick and fast for me, please. You have 2 minutes. Negative 2.86 squared. Negative 2.86 squared minus 2 minus 2. What we get?
So I got 41.8.
What's 1.8?
Yeah. 0.
All right. And then the last statement I'm going to write now is which one bigger?
One of the negatives.
Right. So my absolute maximum is 41.80 at negative 2.86, comma negative 2.86. And then my absolute minimum is going to be 18.92 at positive 2.86, comma 2.86. Done. Finito, finito. All right. Now, what this suggests to me, because I'm hearing, a very hollow moment. If I drop a pin, I can't hear it. It means that we need to spend some time looking at this. Spend some time looking at this. What I'm happy about that I did tonight was to write the steps. So to do the Lagrange multipliers, we have 5 steps. Study the steps. This is how we're going to study the topic. Give me just 2 more minutes and then I wrap up. This is how we're going to study the topic. Simply study your steps. Study your steps. So that your first step is actually to differentiate the function in conjunction with the constraints and then equate. You get marks for those. You have the 2 equations, you get you 2 marks. And then what you're going to be doing is just pure algebra to solve for x and y in terms of lambda. Once you solve for x and y in terms of lambda, the third step is for you to substitute those values, x and y in terms of lambda, into the constraint. And then when you do that and you substitute into the constraint, your aim is to solve for lambda. When you solve for lambda, that's step 3. So step 3 is the longest. When you solve for lambda, what you're going to do next is to substitute the value of lambda into step 2, into your original, into your step 2 thing where you have your x and y in terms of lambda. When you substitute your value for lambda into step 2, you're going to get your coordinates. And then that's step 4 to substitute. And step 5 is to substitute into the original function and get what your stuff. And then if you want, well, step 5, and then again, I want to say classify because I don't want to mix you up, right? You can get 2 positive values, but one of them is still minimum. Why? Because it's smaller than the other. All right, here's the plan. Look over that. Big up on yourself. And remember, Edicus is there. Go through the notes again. If you get a little time tonight, go through this tonight before you go to your bed so that you don't lose it. Have a good one later.
Sir, when is the mid-semester?
Talk to you about WhatsApp on that one.
Okay.
Cool.
All right, sir.
Yeah, man.